Megaminx Blindfolded is difficult because there's so many different pieces to memorize and the setup moves are difficult to keep track of. But I believe that the method that I've developed does a good job addressing both of these issues. If you don't know how to solve a 3x3 blindfolded, I would recommend learning that first, because there are basics of blind solving that I'm not going to cover in this video that are pretty necessary to be able to solve a Megaminx blindfolded. With that said, let's get into the tutorial. First I'm going to go over execution, then memorization, and then I'm going to do a short example solve. On a Megaminx, the edges and the corners move independently of each other. So you cannot have a case like this, where you swap two edges and two corners. You always have to do 3 cycles of whatever piece. And because of that, there's no way to do a traditional old Pacman solve on Megaminx. Because of this, you can't solve with just a buffer and a swap position. You also have to introduce a new idea called a slave buffer. So if I were to do that on 3x3, I would use this buffer, this slave buffer, and this as a swap position, and I would use an A-perm to swap these pieces. So in this example, this piece needs to go here. So I'll set that up to the swap position, and then to get this to here, I'll do a counterclockwise A-perm. And now that's solved, so I'll undo the setup move. Now, the slave buffer went into the buffer, and this piece went into the slave buffer. So next, I'm going to swap to this, so I'll do a setup like that. But instead of doing a counterclockwise A-perm, I have to do clockwise this time. And then I'll undo the setup move, and now the cube is solved. On Megaminx, I solve the corners first. And for corners, I use this piece as a buffer, this as a slave buffer, and this as the swap position. And the alg I use is a commutator, which is of the form AB, A', B. A is called the insertion, and it inserts this piece into the top layer. And it's R', D', R. So the piece that was here is now in the top layer. B is the interchange, which is where I interchange these two pieces, and that's simply U. So then I would do A', which is R', D, R, and then B'. And these 3 pieces have moved, and nothing else has been changed. So on Megaminx, I always do pieces in pairs. So looking at the buffer, I see that that needs to go here, and that needs to go here. So I'll have this pair of pieces, and I'll execute the first piece first. So I set it up to the swap position, and then because this is the first piece of the pair, I do interchange first and insertion second. So I'll do interchange, insertion, reverse interchange, reverse insertion, and then undo the setup move. And this piece is now solved. Now I'll set up the second piece to the swap position, and because it's the second piece, I do interchange second and insertion first. So insertion, interchange, reverse insertion, reverse interchange, and then I'll undo the setup move. So the easiest way to remember this is whatever the number of pieces, that's the order you do interchange. So if it's first piece, you do interchange first, second piece, you do interchange second. Now the last thing about corners that I want to talk about is what happens if you track into the slave buffer. So in this example, the buffer will go here, and then that goes here, which is the slave buffer. So to execute this, first I want to solve this piece, so I line it into the swap position, and then it's the first letter of the pair, so I do interchange first, and then insertion, reverse interchange, and reverse insertion, and then I'll undo the setup move. Now because each time you do a cycle, not only are you dropping one of the top pieces into the swap position, but you're also swapping these two. If you want to swap these two, you don't have to do anything because the swaps will cancel out. So if you do get the slave buffer as a piece of the cycle, you just don't do anything and move on. This case is more tricky. So this piece in the buffer will go right here, and then this piece goes to here, which is on the slave buffer, but it's not in the correct orientation. So similar to the buffer, you can't shoot to a different sticker that's on that piece. So what you have to do is put this piece into that top there, and then just remember that it's misoriented. So if this orange is on the top, this black will be right here. So I'll have to apply moves at the end to orient these two pieces correctly. So to do this, I would set this piece up to the swap position, and then it's the first letter of the pair, so I do interchange first, and do the commutator, and then undo the setup move. Now I have misorientation, so I'll put these two on the bottom, and then do a sequence of sexy moves. If the black is on the front, you do 4, and if it's on the side, you do 2. So now I'm going to go over corner setup moves. You always want to have a pattern for your setup moves because you need to do it the same forwards and backwards. If you do it differently, it'll mess up some of the pieces and you'll end up with a DNF. So you have to have a pattern to keep it the same. For corners that are on a face adjacent to the bottom, I'll always set it up to this face right here. So for example, if my corner was the yellow with light green and blue next to it, I would set up to this bottom left face, and then I set up to the bottom right piece of that face. So this is right here, I'll set it up down there, and then I do a downright 2 to put it in the swap position. So then I can do my commutator and then undo that setup move. And that applies to all the pieces on the faces adjacent to the bottom. For a piece on the bottom, I set up to this position right here on the top left. So if this was my piece, I would set it up here, and then I do downright 2 prime to put it in the swap position. And then I do my commutator, undo that move. The top layer is where it gets more tricky. So if it's in one of these 3 positions on the top face, I will align it with this face and then turn it to this position right here, and then align it to this face. So for example, if my piece was the light green with yellow and blue, I would align it with this face, move it here, and then align it to the swap position. And then I do the commutator and then undo the setup. If it is in a top position, I would first move it out of that top position while preserving the 2 buffers, and then do a case either top or bottom face. So for this one, I can easily just align it right here. This one's a little more tricky because I can't turn this face since the slave buffer's right there. So what I have to do is put it on the bottom face, align it right here, put it in the bottom right, and then put it up to the swap position. And lastly is these 3 top pieces. And for those, I will simply just bring it down into one of the top faces and then follow the rules from before. Next, I will cover edge execution. And edges are very similar, but with one minor change. So I have a buffer right here and a slave buffer right here, but there's 2 swap positions. This right here and this here. And I could use 1, but using 2 makes it easier because I have 1 for pieces in the top layer and then 1 for pieces in the bottom layer. So I'll show you both of the commutators. For this swap position, the interchange is U2 and the insertion is RL prime, F prime, R prime L. So then that's reverse interchange and this is reverse insertion. And then for the swap position on the bottom, the interchange is the same. It's a U2. and then the insertion is R L prime F prime 2 R prime L. So then this is the reverse interchange and this is the reverse insertion. The ideas that apply to shooting to a slave buffer on the corners are the same with edges. There is a difference, however, with orientation. On corners you can fix orientation by doing sexy moves, but that's not possible on edges, so you have to use an alg to swap two edges. So this alg will swap the left and right, so if it's the buffers you have to do a setup move like this, and then do this alg. R prime, U prime, R, L, F, R prime, F prime, L prime, U prime 2, R, U prime, R prime 2, U prime 2, R. And then undo that setup move and the corners are flipped correctly. So now I'm going to go over setup moves. If the piece is in the bottom layer, I'll just set it up to this face right here and then align it to this swap position. So for example, if it was red with blue, I would align red here and then move that piece to the swap position, do the commutator, and then undo this setup move. If the piece is in the bottom layer, I align it to here and then I do a downright 2 prime to put it in this swap position. Then I can do the commutator and then undo that. If the piece is in the top layer and it's in one of these 4 positions, I'll align it to this face and then move it into the swap position. So if it was the pink and red, I would align pink with the right face and then move it into position, do the commutator, and then undo the setup move. If it is one of these pieces adjacent, I simply move it. So for this piece, I would move it out of the way, and then I can do the alignment. And lastly, for pieces on the top, it just applies to these 3 that aren't the buffers. I'll do a move that puts it into either the bottom or the top layer and then follow from there. Now that I've covered execution, I'll move on to memorization. I use letter pairs to memorize the Megaminx, similar to what I use for 3x3, but on Megaminx there are 60 stickers of each type of piece, which means you can't assign a single letter to each one if you're just using the English alphabet. So to alleviate that problem, I assign each sticker both a color and a letter. And when I make a letter pair, I mix the 2 colors and the 2 letters into one combination. So I have 3 groups of letters on the Megaminx. The first group is yellow, and that's the top and bottom, and it goes A through J. So for corners, I letter A, B, C, D, E, and then edges are A, B, C, D, E. And then the bottom is F through J. The faces adjacent to the top are blue, and I letter corners A, B, C, D, E, and edges are A, B, C, D, E. And this blue group goes from A to Y. The last group is the red group, and this is also A through Y. And for these, I letter A, B, C, D, E for corners, and A, B, C, D, E for edges, on through until Y. So when I have 2 pieces, I organize them into a letter pair that has a color. And letter pairs are made normally just like with a 3x3, but the color is determined by the combination and order of the colors of the pieces. So if both pieces are blue, the letter pair will be blue. If both are red, it'll be red, and if both are yellow, it'll be yellow. If the first is blue and the second is red, it's purple. If the first is red and the second is blue, it's pink. If the first is blue and the second is yellow, it's green. If the first is red, the second is yellow, it's orange. And if the first is yellow and the second is blue, it's black. If the first is yellow and the second is red, it's white. And these are kind of arbitrary, but after doing a number of solves, I quickly got used to them and didn't even have to think about it anymore. So I'm not going to go over tracking and memorizing because it's very similar to a 3x3, but there is one thing to keep in mind, and that is knowing when to stop. On a 3x3, it's fairly easy to know when to stop because there's only 8 corners and 12 edges, so you'll have a fairly good idea of when you've memorized all of them. But there's not really a good way to do that on Megaminx since there's so many pieces. So what I use is an equation to know how many pieces I've solved. And the equation is this: the number of letters that I've memorized plus 1 minus the number of cycles I've broken into. So let's say I'm memorizing and I'm doing edges. I haven't broken into a new cycle yet, and I arrive at this piece and it's my 28th letter. So this takes me back to the buffer. So I have memorized 28 pieces, I add 1, now it's at 29, and I've broken into 0 new cycles. So I have 29 pieces accounted for, and there is 30 edges, which means that 1 edge is solved. And that one's right here. If I was in a similar case, where I arrived to this piece as my 28th letter, I would know that that goes back to here, and I would have 29 pieces accounted for. However, this is flipped, so my 30th piece is not solved, it will also be flipped. So I need to find where that is, and it's right here. So what I would do is execute those 28 letters, and at the end, bring this piece into the top layer and apply the flipping algorithm. Let's take a look at this example. So say I memorize some pieces and then I get to here, which goes back to the buffer. So then I open a new cycle with the slave buffer and keep memorizing, and then I get to here, which goes back to the slave buffer. So I'll memorize this and then close out that cycle. And that would be, for this example, that's my 24th letter. So I'll do the equation. 24 plus 1 is 25. And I broke into 1 new cycle, so I'll subtract 1. I have 24 pieces accounted for. So I'll look around, I spot that one solved, but I don't see anything else solved. So 24, and I have this one accounted for, which means there's 5 other pieces on this puzzle that I need to solve. So what I have to do now is break into another cycle. The same idea applies to corners, but with corners, instead of 30, there are only 20 of them, so you only need to get 20 corners accounted for. So now I'm going to do an example solve, but because a Megaminx takes so long, I'm only going to do a partial solve. So I've reduced the number of corners from 20 to 8, and I've reduced the number of edges from 30 to 12. So I'm going to base this solve off of that. So let's begin. I'm going to memorize edges first, so I'll start here at the buffer. This goes to red B, which goes to blue W, so that's a pink bowling ball. And then that goes to red Q, which goes to blue I, which is a pink quill. And then that goes to red M, and then yellow G, which is orange magnets, and then that's the buffer, but it's swapped. So I have to remember that the buffer is swapped. Now I'll break into a new cycle, and the easiest way to do that is with the slave buffer. So I'll remember yellow B, and then that goes to yellow E, and that'll be a yellow B. So now I have 4 images that I'll make into a bigger image. So a pink bowling ball being drawn on by a pink quill, and it's drawing orange magnets being carried by yellow bees. So that's my first big image for edges. Next, after yellow E was this is red O, and then that is blue K, so pink Obi-Wan Kenobi, and then this goes to red U, and that goes here, but I can't shoot there because it's the slave buffer. So I'll have to shoot to this piece right here and remember that it's flipped. So that's red U and then yellow B, which will be orange Usain Bolt. And now I've just finished a cycle and I have 12 letters. So 12 plus 1 minus 1 cycle break is 12. And I had 12 edges, so they will all be done. I have to remember that these two are swapped though. So my edge memo is a pink bowling ball being drawn on by a pink quill, and it's drawing orange magnets carried by yellow bees, and then pink Obi-Wan Kenobi racing orange Usain Bolt. Now I move on to corners. So this corner goes over here, which is red M, and then that goes up here, which is blue Q, so that makes pink mannequin, and then this goes to here, which is red U, and that goes here, which is red F, and that'll be a red UFO, and then that goes to the buffer, but it's flipped, so I'll have to remember that the black is here. So now I need to break into a new cycle, and this piece hasn't been used. So I'll memorize this piece right here. That's yellow D, which goes to red D. So together that would be white dad. And then this piece goes here. So that's blue R, which goes here. And that's blue A, which will be blue raccoon. And now I've got back to the piece I broke into the new cycle with, and black was here, I swapped over here, and then I ended on this. So they will be solved. And I have 8 letters. I broke into one cycle, so 8 plus 1 minus 1 is 8. And I had 8 corners to worry about, so I'm done. So the corner memo is a pink mannequin abducted by a red UFO that's driven by a white dad and a blue raccoon. Okay, now let's move on to execution. So the first letter pair of corners is pink mannequin. So I'll start with red M. I move that to this face here, put it in the bottom right, bring it up to the swap position, and then it's the first letter, so I do interchange first, and then finish the commutator and undo the setup moves. Next is blue Q, which is here. So I'll set that up to here and then align it with the swap position. It's the second letter, so I do interchange second. Insertion goes first, then interchange. And then I undo the setup move. So next was red UFO. So first is red U. I'll align that to this face, put it in the bottom right, bring it to the swap position. It's the first letter, so interchange first, then insertion, reverse interchange, reverse insertion. Undo the setup move. Next is red F, which is right here. So I'll put it on this face, bottom right, up to swap. It's the second letter, so interchange comes second, insertion's first. And then I'll undo the setup move, bring it back. Next was white dad. So the first piece is yellow D, which is here. I'll bring it into this piece and then put it in the swap position. First letter, so interchange first. Undo the setup moves. And then red D, which is here, so I just move that here and then up. It's the second piece, so interchange is second. Undo setup, and then blue raccoon. So R is here, so I can simply move it over and it'll already be in the swap position. It's the first letter, move it back. And then lastly was blue A, which is here. So for this piece, I'm going to bring it down into this face, put it in the bottom right, and then bring it up. It's the second piece of the pair, so interchange is second. So I do that, and then undo the setup, and all the corners are solved. So now let's go to edges. The first letter pair was pink bowling ball, so B is first. I will move it over to this face and then put it in the swap position. It's the first letter, so interchange is first, then I do insertion, reverse interchange, reverse insertion, undo setup. Next was blue W, which is right here, so I'll put that in this face, put it in the swap position, and then it's the second letter, so interchange is second, undo the setup. Next was blue quill, no, pink quill. So first is red Q, which is right here. I'll put that in this face and then align it with the swap position. Interchange first, undo setup, and then came blue I, which is already in the swap position. So all I have to do is the commutator to solve that piece. Next was orange magnets, which starts with red M, that's right here. So I'll do that move to align the face and then put it in the swap position, interchange first, and then undo setup. Next was yellow G, which is right here. So this is already in the position I want it. I'm just going to rotate it up into that swap position and then interchange second because it's the second letter. Now it's in that. So I'll undo setup. And now we move on to yellow B. So yellow B is already the slave buffer, so I don't actually have to do anything to execute that letter. So I move on to the next letter, which was yellow E. For this one, I would put it in this position on this face and then just rotate it into the swap position. It's the second letter, so I do interchange second and then undo setup. And now we have pink Obi-Wan Kenobi. So the first letter was red O. I'll put that in this face, move it up, and then interchange first, undo setup. Next is blue K. That's back here, so I'll put it on this face, rotate it down, interchange second, undo setup. And lastly was orange Usain Bolt. So red U, I align right here, and then interchange first. And then lastly is yellow B, which again, you don't have to do anything for. So now I'll just do the flipping alg. And it's solved. Thanks for watching this video. I hope it helps. I will link my original tutorials in the description. They were a little bit longer and provide more detail, so if you'd like to watch them, go ahead. Or if you have any questions, just leave them in the comments below and I'll try to respond as quick as I can.